Hi, everybody. Welcome to this webinar. My name is Siraj Raval. I am head of developer education at Polygon. Polygon is one of the biggest cryptocurrencies in the world, and I have been working at Polygon for almost a year now. I love it. I've been in the cryptocurrency space for many years. Back in 2014, I published a book for O'Reilly called Decentralized Applications, Harnessing Bitcoin's Blockchain Technology. And ever since then, I have been very interested in the cryptocurrency space. I have a YouTube channel with my own name, Siraj Raval, almost 1 million followers, where I talk about cryptocurrency, artificial intelligence, advanced technologies. And all that is to say, I'm very excited to be here at the United Nations. This is a very important community. It's a global community, and it's one where we should focus on solving high impact problems that are humanity's hardest challenges, the Millennium Goals, right? Poverty, water cleanliness, social equality, climate action. All of these things are massive problemms that are going to require humans that are super collaborators, people who can collaborate at scale. And that is really the theme of the blockchain space in 2022. The theme is scalability. And that's not a news story. It's actually been scalability for the past 3 years. And I want to take you guys on a little bit of a history lesson with me today as we go into what the issues are with the blockchain space and what the solutions are. And then finally, what you and I can do to build on top of that. What can we build that's actually going to affect somebody in their day-to-day life? So let me start sharing my screen now, okay? I want to show you something that I've never shown anybody before. I want to show you this new website. This new website is called Coinbase NFT, and I just got access to it. It's a beta. It's not out yet for the public. I only got access because I already have a few other things I've signed up for on the waitlist for Coinbase. But let's check out this platform, shall we? This is a new NFT marketplace by one of the biggest cryptocurrency companies on the planet, Coinbase. Let's take a look at Coinbase NFT, shall we? So if we go here, we're going to see a bunch of these non-fungible tokens. These are JPEG images that have attached to them a unique 25-character address. And this unique address, we can go to shop and we can click on one of them. Let's see, basement dwellers. This right here, we can just right-click, save image as, and we now have the image. But what we don't have is we don't have this address. There's a 25-character address associated, a wallet address with each of these JPEG images. And if we want to buy one of these for, let's say this is 0.12 ETH, we can click on buy now. And this all new payment flow pops up that the world has never seen until today, apparently, which is Coinbase's NFT marketplace user interface. And what we can do is we can purchase this JPEG image. And what's the difference between purchasing it and right-click saving as I just did? The difference is that I get ownership over this 25-character address on what's called the blockchain. And this address is akin to a digital patent. So if I today, or if you or I wanted to just make an iPhone, we could do that. We could gather all the materials we wanted and we can make an iPhone, except Apple would come after us, right? Because what does Apple have on the specific configuration of atoms known as an iPhone? They have something called a patent. And that's what an NFT is. It is a digital patent. It applies globally. It is cross-national. It is cross-border. Exactly what the United Nations should be interested in, right? We want a global village. We are a global village, and we need to find ways of coordinating, of reaching consensus on major decisions, of agreeing on things. And this idea of a global ledger where we have a patent system that is not limited to a single geographic location is a very powerful idea. And it starts with something funny and silly like this, where we're buying something called a basement dweller's pass, but it then extends to something much more profound and impactful, which is what we're going to go into. So recall, on this website, we can buy this with ETH, which is the currency of Ethereum. Unfortunately, we don't have ETH with us today, so we're going to go to a different NFT website called OpenSea. Now, OpenSea is very similar to Coinbase's NFT marketplace. Now, most of you, or a lot of you, probably have visited OpenSea. What we can do on OpenSea right here, right now, is we can mint an NFT. You guys have heard of this process, haven't you? Like minting an NFT. let's mint one ourselves, shall we? We want to mint an NFT live right now in real time, and we're going to see what it takes to mint an NFT. What I'm going to do is I am going to take a random image. I'm going to mint a random image. Okay, so I'm going to mint this random image called me. It's a picture of me and a dog, NFT. And I'm going to say this NFT, I want to mint 99 of them. But unfortunately, it's only going to let me mint one of them because it's on the Ethereum blockchain. But turns out they have another blockchain called Polygon here. And Polygon is a different blockchain that allows you to mint not just one, but how about 100,000 NFTs all at the same time? And if we click create on 100,000 NFTs, if we verify that we are in fact humans, then we can check to see if this is going to work after I verify I'm a human. There we go. So all of a sudden, within 15 seconds, we just minted 100,000 NFTs on Polygon. And we have this location. We have an address here. We can say it's minted here. We can sell it to someone. We can list it for sale, all this stuff. So that's how easy that was on the Polygon blockchain. And so let's talk about how that just worked, shall we? We want to know what just happened behind the scenes. So if we go to this visual right here, this is a visual at andersbrownworth.com. Very good learning resource for you guys. So definitely bookmark this link, andersbrownworth.com. So if we go to this link, we're going to see this visual right here of what's called a block. And this block has 4 different text input fields: block, nonce, data, and hash. So the block is the number of the block. The nonce stands for number only used once. It's a unique identifier. Data is obviously empty, and hash is a 25-character alphanumeric key that represents a unique block. So what we can do is we can look at this block and we can see that it's green. Great. Green means go. Green means things are great. Now, if we go into this data input field and we type in something, all of a sudden the block turns red. And not only did the block turn red, notice as I type, the hash is changing, right? This hash, what's happening as I type more and more, as I add data to the block, this hash is being recomputed in real time. Because what the hash does is it's supposed to represent all of the data inside of the block, but it's not doing it properly. It just knows that the data has changed. What do I have to do to compute an exact hash that when used, that hash, I can actually reverse engineer that hash and get the data, right? How do I do that? Well, I have to do this process called mining. And once I click on this mine button, the block is green again because the hash has been recomputed to correctly represent whatever data is in the block. And this process of mining is different for different blockchains. For Bitcoin, it tries to brute force solve random mathematical problems. For Ethereum, it does the same. For Polygon, it does not do that. For Polygon, it actually does something very differently, which we're going to go into. This is the original idea of a blockchain, where we have all these blocks, and we have all this data, and we have all these hashes, and they're all linked together via pointers. Pointers are a concept in computer science where one data structure can be linked to another. That means that there is an edge in the graph where data can flow, and this can be one way or two ways, back and forth. So this is like a linked list, essentially, from data structures and algorithms. And notice that whenever I type in some data into the block, every single block in the chain breaks. By breaks, I mean they're all red, but not the ones that came before that, right? So everything before on the left is going to stay green, but everything afterwards is going to turn red if I change anything. Why is that? Well, once I click mine here, it's going to make it's going to make these blocks green. And why did I have to do that? Well, the reason is that this is a blockchain. All these blocks are data structures that contain random data in them. They're all linked to each other. And in the grand scheme of things, in the actual Bitcoin blockchain, the biggest blockchain in the world, that's what's happening. There's this chain of blocks. And inside of the data text fields, it's not random characters that Siraj types in. They're a list of transactions that everybody has sent to each other. It is a ledger. It is a database, but it's a public one that everybody can see. And that's Bitcoin. But Ethereum is very different. Ethereum says, let's take that same idea of Bitcoin and instead let's put code inside of that data field. So notice that there was a data field here. So Bitcoin is saying Siraj sends, Bob 2 Bitcoin. And then the next one is Bob sends John, 3 Bitcoin. And that's how Bitcoin works. Inside of this data field are all of these transactions, but Ethereum works very differently. Inside this data field, we have instead some code, right? So it's not going to look exactly like this. This is called a for loop. For int x equals 0, x is less than 50. And we're just going to create a loop here. It's going to be a counter loop. It's going to increment 50 times. And then for all 50 of those times, it's going to say, check the weather. So it's kind of a weather object, weather.check, where the parameter is going to be a place, like say Dallas. And then it's going to return a weather amount. It's going to be an int temperature. And it's going to do that 50 times. And if the temperature, if all 50 of those times, if the temperature is greater than 65 degrees Fahrenheit, then and only then will we do something very unique. We will make a green light dot on. We'll turn it on. And that's just a random example that we just made right now, but you get the point, is that there's some code inside of this block in the Ethereum blockchain. Now, why would we want to put code inside of this weird database? Why wouldn't we just want to take our code and go to some, website where we can upload a web app or a mobile app like Heroku, where we could just sign up. We can say, all right, here's our code, upload it, run it, deploy it, scale it. You guys have solved everything years ago, like over a decade ago. Why are we trying to put this code into this weird little block data structure that's linked to other blocks that everybody can see? So, this code is not open source. If I put it in this blockchain, everybody can see my code. Why would I want that? My code is terrible. Why would I want everyone to see it? Well, there's a reason we want everyone to be able to see the code. And I'm going to explain to you that reason right now. The reason we want everyone to be able to see the code is if we were to, create some sort of decentralized finance protocol that had 17 billion with a B dollars locked in there, we might want to have that code that drives that platform be auditable by the community. Now, does it have to be auditable by the community? No, you just need 3 or 4 people and you have to trust them to do that. But clearly, there have been cases throughout history where small groups of people have not made decisions that are in the best interest of the majority. Wouldn't you agree? So, ideally, when it comes to these online networks that are used for different applications, whether it's finance or marketing, sales, supply chain, scientific research, whatever it is, it's just better if it's more transparent because we now live in a global village and we want the world to be able to trust each other. And that's what these systems are for. Blockchains are not trustless systems. You're going to hear this word trust a lot. I don't have to trust anybody anymore if I use a blockchain. And the reality is that we will always have to trust each other. Trust is a part of the human condition. We'll never get around it. And so what these systems do is they make it easier to trust each other. They are more trustful systems. They are not trustless systems. So Aave, for example, is a more trustful system than some closed example like a bank, for example. Because if we go to Aave and we launch this app, this is a Web3 app. And how do I know that something is a Web3 app or it's a Web2 app? Well, I know because there's going to be something called Wallet Connect in the top right-hand corner. And I can disconnect so you can see this process. And I can connect. And what it's going to do is it's going to connect to my browser wallet. My browser wallet, in this case, is MetaMask. There are different types of browser wallets. You want to have a browser wallet if you want to interact with the Web3 space. So this browser wallet has no money in there, but the point is that I've connected to it. And now that I've connected to it, I can perform a series of actions using it on this interface. So let's go through this and we can see that if I want to earn interest on my tokens, whatever they are, I can stake them on the Aave platform. Right here, I can see I can get a 7% APR on my Aave token. But it's not just Aave coin that we can stake here. There's many other coins. USDC with an 11% return. It's quite high. It's quite high. It's not going to be so high on other platforms. But that's what we have here. And that's the DeFi protocol. If we wanted to deposit money in here, we could do that. We could do that. But who's in charge of our money? Like who Who is going to be held accountable for this money? And the answer is not a group of small people, but the entire community, because what we're looking at right here is the code for Aave. So we just saw a web app that supposedly holds $17 billion inside of it of users' funds. It's somehow secure, and the code is publicly auditable and available right here on GitHub. How is that possible? You don't want that, right? With $17 billion, you don't want your code to be visible to any potential hackers, right? Well, the answer to that question, in terms of security of funds when the code is open source, the answer to that question is that the code is auditable and it is secure, and it is just as secure as a bank or any other central source. And why is it secure? Well, we talked about blockchains. We talked about this idea of mining and how mining ensures that all of the data across the entire chain of blocks is valid, whatever that means. But in terms of security, when it comes to all of these different protocols, all of these different protocols have different security layers. For Bitcoin, for someone to be able to hack into Bitcoin and try to mint some fake Bitcoin, they would need more computing power than the 500 fastest supercomputers in the world combined. Nobody, no government, nobody has that much computing power. That's why Bitcoin's still around, even though the code is open source. Ethereum, some similar number like that, some godlike amount of computing power, and that's why nobody's ever been able to do that. Now, some of these coins, like USD coin, they are totally centralized and they are issued by a central authority. That means their supply is very closely monitored. Now, does that mean there's going to be certain security risks that some coin, like say Bitcoin, will not have? The answer is yes, right? They all take different sets of trade-offs. And what are those trade-offs? Those trade-offs are, we are going to continually come back to them throughout our time in the blockchain space. We call those trade-offs the scalability trilemma, where we have scalability, security, and decentralization. We can only pick two of three. And often has been the case that in these blockchain networks, we have picked security and we have picked decentralization, but we have not picked what I said was the theme of 2022 and the theme of 2021, scalability. So that's the idea. Like, Ethereum is super secure, it's super decentralized. We can write code that goes into these blocks and build on the Ethereum network, and it's going to make these powerful applications that can run billions of dollars, that are open source, transparent, incorruptible, largely incorruptible, and just a better model of just every single idea you could possibly think of, right? What is, just take any existing business idea, add more transparency, openness, and a global user base, inherently global. All cryptocurrency is inherently global as well. If you've ever had an online business and had to deal with payments using Stripe, or Stripe is amazing, but like Stripe or any one of these payment providers, PayPal, you have to make certain adjustments for different countries and different banking regulations and government, right? All that stuff falls in the face of an internet native digital currency, whether it's Bitcoin, Ethereum, etc., Polygon. But speaking of Polygon, the reason that I work at Polygon and not Ethereum is because Ethereum, for the past few years, has faced a very difficult problem, and that problem has been scalability. How do we scale Ethereum? Because what's happened is that we have had all of these incredible dApps that have been built with Ethereum, but none of them have really been able to scale. So if we go to the Polygon website, we can see that we have all of these dApps, and we will be able to see what the entire ecosystem looks like. We have over 19,000 dApps, decentralized apps, that have been built with Polygon. And we can go through this list. We can just pick some at random, and we can see what they're like. We can see what their website is like. We can learn a lot about them here, but almost every single idea when it comes to dApp development that you could think of has been thought of, but there's a lot to do. There's a lot of potential here. Nobody has done a lot of these things at scale right. Like, for example, a social network. We haven't seen a social network, a decentralized social network, done at scale correctly. But there's a lot of examples here of decentralized apps that have scaled with Polygon that have been built. Now, I want to talk a little bit about that scalability bit because that's really the last remaining piece here to the puzzle. I think you've gotten a nice picture of what Bitcoin is like, what Ethereum is like, what some of the decentralized applications that arise from these technologies are like. But let's talk about Polygon and scalability. So you have this blue, you have these green blocks. Remember these three green blocks. And I was showing you these right here, right? This is the Ethereum blockchain. And it's just chugging along the Ethereum blockchain. It's just processing all these transactions and all these transactions are happening. And then all of a sudden, let's say you and I decide to make these decentralized Uber. And so all of these ride requests are going into the Ethereum blockchain and we're scaling up to tens and hundreds of thousands of users. And once we get to hundreds of thousands of users, whenever a user wants to make a ride request, it turns out the gas fee, because remember, in a Web3 app, everything must interface with the wallet. Everything is a transaction. That doesn't mean the user actually has to pay real money, but everything is a transaction that gets recorded in these blocks. So ride requests are going into the Ethereum blockchain, but the gas fees are getting too high. What do we do? Instead of deploying that same exact dApp with all of its code, HTML, CSS, JavaScript, the web stack, and then Solidity for smart contracts. That's what we add for smart contracts. So what we just showed here, this is a smart contract. Any code that lives inside of a block, inside of a chain, is called a smart contract because it cannot be destroyed. You cannot shut it down like you can a server. In order to take this code and delete it, once it's deployed to the Bitcoin blockchain or the Ethereum blockchain or the Polygon blockchain, we would have to destroy the entire network. And that's why it's called a smart contract, because it's a contract that is smart. It doesn't require you. It doesn't need you. It lives outside of you. It is almost like an autonomous contract. You could think of it in that way too. So we have that code, we have Polygon, we have Ethereum. And so what we're going to do is we're going to take that dApp that we would have deployed to Ethereum, and we're going to deploy it instead to this blue chain of blocks called the Polygon blockchain. This is a separate blockchain entirely. And once we deploy it to the Polygon blockchain, which is a fork of Ethereum, by the way, what we have right now, Plasma sidechain, then what the Polygon blockchain will do is, using its consensus mechanism, which is not using proof of work, random math problem solving, it's using proof of stake, which means that there are these people called validators that are going in, these icons of people that are going in and approving all these transactions, and they are delegated, their money is delegated to them by the network. And these approvers are going to take all these transactions that are happening and they're going to take them, they're going to compress them into a single data packet, and then they're going to send that data packet every so often to the Ethereum blockchain. And instead of us having all of our transactions computed on the Ethereum blockchain and then our users having to pay out huge gas fees for that, instead of that, we're going to have all of our transactions computed on the Polygon blockchain, which is essentially free because we use a different consensus mechanism, proof of stake. And then we're going to send that data to Ethereum. Well, not we, but the Polygon validators will send that data. So what does that mean for us as developers? That means we just got to build an Ethereum dApp without high gas fees, and it's much faster. And that's why I work at Polygon, because Polygon lets developers build Ethereum dApps that actually scale. That's what Polygon's all about. Because what do we want to do? We want to bring the world to Ethereum. Polygon believes in Web3 for all. It is a decentralized Ethereum scaling platform that enables developers to build scalable, user-friendly dApps with low transaction fees without ever sacrificing on security. We are built for developers, by developers. And Polygon is actually several things. It is a suite, it is like a Swiss Army knife of Ethereum scaling solutions. What I just talked about was Polygon POS, proof of stake. It is an Ethereum compatible sidechain. We can deploy our dApps to it very easily. And we have a documentation on how to do that. It's awesome. Then we have all these other much more interesting and technically specific niche products like Hermes. Hermes is this idea called a ZK rollup, a zero knowledge rollup, where we have all of these transactions, let's say thousands of transactions, and we roll them up into one transaction, like I say, a validator, and it's like a tree and it represents all those transactions. And that's what we send to the Ethereum blockchain. And because the data is smaller, we all win. So that act of data compression and sending that to a different blockchain. That is a ZK rollup. And that idea is actually very complicated on how to do that well while keeping the identities of the people on that blockchain private, so that the main chain where we send it to has zero knowledge. There's Avail. Avail is for data availability. When do you always need data online, right? Whether maybe that's an energy grid, maybe that's a supply chain. There's Polygon Nightfall. This is another type of ZK rollup. This uses something called ZK Starks. We have ZK Starks, and then we have ZK Snarks. And these are two different methodologies of compressing data. There's actually a third, Polygon Maiden, another way of compressing data, and Zero. So all of these are different ways of solving that key issue that I kept alluding to at the beginning, which was scalability. And Polygon is laser focused on scalability. And Polygon has spent over $1 billion US on scalability. We are trying to go carbon negative this year and climate positive beyond that. I know the UN cares about that. We care about that very deeply. And what does that mean, by the way, like going carbon negative? So, when we think about this process that I just showed you of mining, this, where it's computing, that process right there, right in this browser, that took nothing. But actually, in reality, you have these giant, massive, larger than life server farms that are hosting these mining machines for Bitcoin, and they're as loud as a World War II air horn. They're very loud, and they take a lot of energy. And energy, right? Energy is what drives all of civilization. Energy is upstream of everything else. And the more energy we have, if we had free energy, we might even have free money. Think about this. I want to leave you with this idea, and it's something that I've just kind of been thinking about in my head so far as we end this. Part of the reason that I'm personally at Polygon is I want to make money irrelevant. And I think that that is a goal that we can get to in our lifetimes. But in order to get there, we need to have several pieces of a larger puzzle put together. And as we are here at the United Nations and we're thinking about these massive problems that are going to affect billions of people, one thing in particular that I think we should all be doing as an example is mining our own cryptocurrency at home. And that could be Polygon, that could be Bitcoin, that could be Ethereum, whatever you want. But there's different ways of mining. But one thing that mining has in common across all cryptocurrencies is a need for energy. And there's different ways of generating energy for essentially free. We can have solar panels, we can have wind, batteries, geothermal, lots of different sources of energy. But there's one in particular I think would really change everything forever, and that is fusion. And I'll just point you to this website. I'm kind of a noob when it comes to this stuff, but I thought this was really cool. If we could someday just generate our own limitless clean energy and then use that to mine our own cryptocurrency, and then we essentially all just have free passive money just coming in. Free energy is free money. And what happens then, right? What kind of world does that look like if we can generate free energy and we all have just passive income coming in? I think that's a world where people don't have to live to work. I think that's a world where people are much less miserable. There's much less suffering in the world. And that's the kind of world we want to get to. So all of these tools and technologies are really meant to empower people and users. And whether it's Web3, whatever the category of application you're building is, whether it's gaming, NFTs, DAOs, payments, metaverse, whatever it is, can we create something that people have never experienced before, right? Can we create an experience that people did not even dream was possible before? Can we, for example, pay people to walk with Sweatcoin? Can we create a healthier planet? Can we incentivize this healthy behavior? There's so much potential here. Decentralized science, DeSci, that's almost a completely unexplored area of development and research. But my point is that behavior is a result of incentives. So if we change the incentives, we can change the behavior. And right now we have people who are addicted to food and sitting down and not being unhealthy. But if we can, because there's an incentive to do that with these addictive algorithms that these Web2 platforms like Netflix are manipulating our brains with through these two, these eye sockets. And we have 188 cognitive biases in our head, and we are all susceptible to it. It's like an optical illusion. Even if you know it's fake, even if you know it's manipulating you, you cannot help but be manipulated. And that's another reason why we need Web3 is we need these algorithms to be open source. We need the world to be able to audit the type of manipulation that is going into our head. And we need to re-engineer the incentives of society so that it is there to help level us up, not bring us down. So that's it for my presentation here today. I really just wanted to kind of explain how Polygon works and how it works in the context of the larger Web3 ecosystem. Some of the decentralized applications that have been built on top of it, like Aave, like Sweatcoin, like I also wanted to show you an example of how it works, talk about some of the more futuristic ideas of combining cryptocurrency with different sectors like energy and supply chain. But yeah, sustainability, human health, those are two areas in particular I would love to see people from this particular community work on with Polygon. If you have any questions, please do DM me on Twitter at Siraj Raval. I will be available. And if there are any questions after this as well, I will be available as well. Thank you.